Okay, so those were like different key aspects which I wanted to discuss. Now let's follow like the training steps. So what you do is you have the problem, you know what problem to solve. So you know like what will be your network's input and what's going to be the output. And depending upon that, you will first define your network. Okay, so you will be the architecture of the network. You will define how many layers you want, how many kernels you want to use, what should be the shape, all those hyperparameters you will define. So that will give you the network. Then you know that what your network is going to predict, and then you know that what kind of ground truth is available. So using those two values, you will define a loss function. Okay. For example, if we are doing classification, you can use binary cross entropy. We discussed that loss function last time. Of course, that's not the only loss function you can use. That's the most like common one, and it usually works pretty well. Then you will randomly initialize the network parameters. For example, if you have CNN layers, you will randomly initialize those kernels. Okay, so those kernels will have some value. Then you will have the training data. And with that training data, the steps which we discussed earlier, you will randomly shuffle it. You want it to be like stochastic. And then you will prepare batches, like the number of samples which you will use to train your network like for one iteration. Okay. So once you have the batch, you will perform that feed forward operation, which is like you will take each sample and you will run it through the network, which means like you are performing all those transformations, all those filtering operations. So it's going from volume to volume all the way until the final prediction. So for each sample, you will predict something. And within a batch, you will do, let's say your batch size is 16, you will do that for all the 16 samples. And so now what will happen? You will have 16 different predictions for the network, and you will have corresponding ground truths as well. So using your loss function, then you will compute the loss value, like how good your network is doing on those samples. Okay, we'll compute the loss. And then the next step is computing the gradients. So you have the loss function, you will compute the partial derivative for that loss function to all the, with respect to all the parameters. So we'll start from the final layer, and you will use the chain rule to move to the initial layers. So for each parameter in the network, then you will have the gradient value. So that's called like a backpropagation, or you can say like gradient computation. So once you have the gradient value, you know that step from gradient descent, right? So we perform that step for each and every parameter in your network. And that's called like updating the network parameters, and that completes your training process for one iteration. Okay, so you repeat for all the batches. That completes one epoch, which means your network has seen all the samples in your training data. And then you keep repeating that to make your network better and better. Okay, so the loss is going to reduce in each epoch.